Hello and welcome to the video notes for lesson 10.7, volume of pyramids and cones. We will be learning and applying the formula for the volume of a pyramid today and learning and applying the formula for volume of a cone. This isn't a whole lot different than the previous lesson. We're still talking about volume, but we are going to look at the formulas specific to pyramids and cones. So we're going to start off with our warm-up, which asks you to find the volume of each of these figures, which are prisms and a cylinder. To the nearest tenth is where you should round if need to. Go ahead and pause the video to give yourself time to work these out, and then we'll check our answers. Okay, let's continue. We should get the following as our answers. 3,969 cubic feet for our volume of our square prism. Remember, volume formula is base area times height. So we just plug in those measurements, and we get that. For a regular hexagonal prism where the base edge is 24 and the height is 10, we have to find our base area by using our regular polygon formula. Apothem times perimeter divided by 2. Your perimeter would be 144, and your apothem is 12 root 3. Using your special right triangle, you figure that out. So our base area times our height gives us a total of about 14,964.9 cubic meters. And for our cylinder, when we plug in our radius of 8 and our height of 22, we get about 4,423.4 cubic inches. All right, let's take a look at the lesson as it pertains to pyramids and cones specifically. First, let's look at the volume of a pyramid formula given. If we've got any kind of pyramid, and volume doesn't matter if it's a right pyramid or oblique pyramid, the volume of a pyramid with a base area b and a height h is just 1/3 base area times height. Doesn't matter what the pyramid looks like. We can still take the base area, multiply by the height, but then we take 1/3 of that. So let's use that formula as we do example 1. To find the volume of pyramids, we need to know the base area and the height. So in example 1a, we're going to find the volume of our rectangular pyramid, where the length of the rectangle is 11, the width of the rectangle is 18, and the height of the pyramid is 23 meters. Now, to find base area, we're just going to do length times width, because the rectangle is the base of your pyramid. So the base area is 11 times 18, and our height of our pyramid is 23. So our volume is 11 times 18 times 23, or 198 times 23. So our volume is 4,554, but then we have to divide all that by 3. Remember, we take 1/3 of our base area times height for our volume formula. Okay, so when I divide 4,554 by 3, we get 1,518 cubic meters for the volume of this pyramid. Okay, for a square pyramid where the base edge is 9 and the height is 14, you're going to again use this volume formula, 1/3 the base area times the height. Well, that means we need to know the base area. Base area, the base is a square, so we're going to take our side length and square it. So our volume is 1/3. The side or base edge length is 9. So 9 squared is 81. So we have 1/3, 81 times the height of the pyramid, 14. When you do those calculations, you should get the following: 378 cubic centimeters for the volume of that pyramid. Which leads us to being able to talk about the volumes of cones. The volume formula of a cone, where the base area is b and the height is h, is 1/3 base area times height still, just like pyramids. But with our base area, base being a circle, we could be just given the radius, and the volume formula would be 1/3 pi r squared. That pi r squared part takes care of the base area times height. So let's go ahead and take a look at the next example. All right, we're going to use those formulas as we work on these examples. Example 2a, we are to find the volume of a cone with a given radius of 7 centimeters and a height of 15 centimeters. We're going to be giving our answers in terms of pi and rounded to the nearest tenth. So all we have to do is look at this formula. Since we're given the radius, we should use this version of the formula. v equals 1/3 pi r squared h. So let's take a look at what we need to do. We're going to plug in 7 for the radius. So we have 1/3 pi times that 7, and we have to square that. Don't forget to square that first. You have to do exponents before you multiply. And then we have our height of 15. So why don't you go ahead and do the calculations and tell me what you get in terms of pi, cubic centimeters, and then go ahead and round that to the nearest tenth and show both answers. If you need more time, pause the video. Otherwise, go ahead and write your answers there. We should get the following results. 245 pi cubic centimeters, which is approximately 769.7 cubic centimeters. Now, if you're not getting these results, if you're getting something much larger, don't forget to divide by 3. You might be making that mistake. Do 7 squared times 15, then divide it by 3 before we multiply by pi. All right, let's take a look at part B. We want to find the volume of a cone where the base circumference is 25 pi, and the height is 2 inches more than twice the radius. The height is not 2 inches. Please don't see this period here and just stop reading. The height is given to us as something in terms of the radius. So we're going to use our formula, volume equals 1/3 pi r squared h. But in order to find these two, we have to use the given information of the circumference of that base is 25 pi. Since we are given the circumference as 25 pi, that tells you that the diameter is 25, so the radius is half of 25, or 12.5. So our volume is 1/3 pi times that 12.5 radius squared. But then the height, it says, is 2 inches more than twice the radius. So we're going to take our radius and double it, 2 times the radius, and add 2 inches. 2 inches more than means we add 2 to that. So I'm going to take that 12.5 and double it and add 2. When we do that, we get that our height should be 27 inches. All right, I'm going to let you go ahead and do those calculations. You should be good at doing that now. Give our answer in terms of pi square or cubic inches, sorry, and rounded to the nearest tenth cubic inches. Go ahead and do those calculations. If you need more time, pause the video. Otherwise, you should get these results. 1406.25 pi. We don't actually round that. It's the exact decimal 0.25. And then when we multiply by pi, we do round this to 4,417.9. Those are both in cubic inches. All right, you'll notice that the next example is also titled Example 2, but we're not doing the exact same problems. They give you different problems, so we could think of these as parts C and D to Example 2, or you can just call them our other Example 2. Either way, we still need to do these. But once again, look at what you're given here. 34 is not the height of this cone. What is 34? You should have said that 34 is the slant height. Our volume formula for cones does not use slant height, it uses height. So we need to find this height first. The tricky part with this problem is finding that height measurement first. Remember, the radius and this actual height form a right angle, so this is a right triangle where the hypotenuse is 34. Pythagorean theorem can be used again. So we're going to set up our Pythagorean theorem, a squared plus b squared equals c squared. So we're going to write 16 squared plus h squared, that's what we're looking for, equals 34 squared. Take a few moments, pause the video if you need more time, but go ahead and find what h is, and then when you're ready, go ahead and click play to see what the answer should be. All right, we should get h is 30. Square root of 900 is 30. So if our height is 30 and our radius is 16, we should be able to use this volume formula to find the volume of the cone. I'm going to let you go ahead and try and work this out. You'll need to pause the video to give yourself some time. Work this out, and when you're ready, click play, and you'll see what the answer should be to check your answer. All right, this is what we should get. When we plug in 16 for the radius and 30 for the height and do this calculation in terms of pi, 2,560 pi cubic centimeters, and rounded to the nearest tenth, same directions as before, we get 8,042.5 cubic centimeters. All right, I'm going to allow you to try and work out part B on your own. They do give you the height, and notice they give you the diameter. This cone looks a little bit different, but the volume formula is true no matter if it looks like this, a right cone, or an oblique cone. So the volume formula still works. Start with using the volume formula, 1/3 pi r squared times h. Plug in the information and find your volume. Alright, this is what we should get. When we plug in the radius of 9, because the diameter is 18, we get 216 pi cubic meters, which is approximately 678.6 cubic meters. Alright, that sums up our examples that use just basic formulas. Now let's take a look at applying those and going a little bit deeper with this. Let's look at what happens when we change the dimensions in a three-dimensional figure. The diameter and height of a cone are both divided by 3 here. Let's go ahead and look at the original volume and then find the new volume. If I do this in terms of pi anyways, we have a 7.5 radius. So we have 1/3 pi times 7.5 squared times our height of 15. Let's go ahead and write what that is in terms of pi. We get 281.25 pi. But if I take each of these dimensions and divide them by 3, our new diameter would just be 5, and we got to have half of that for the radius. So our radius is 2.5. Our new height would be 1/3 of 15, which is 5. And so if I plug those in, I get 1/3 of pi times 2.5 squared times 5. That volume is 10.416 repeating pi. And that's kind of messy, but if we take that value in our calculator, okay, you see I still have it in my calculator screen, and if I were to multiply that by 3, I would not get that. If I multiply by 9, I wouldn't get that. What we actually need to do is multiply this by 27. Okay, another way we could do this is to take this number, 281.25 pi, and divide it by this number and see what we get. Okay, when we do this, we divide this number by this one, we get 27. Now, your calculator may have gotten you 26.999999, but that's because it rounds to a certain place with this number, but it would be actually 27. And that's because this. If our dimensions are changed by a factor of 1/3, they're divided by 3. We take that dividing by 3 and we cube the 3. We take it to the third power. 3 to the third power is 27. So we can say that our volume is divided by 3 to the third power, or 27. So looking at part B, if we're going to take the radius and height of this cone and double them, we need to describe the effect on that volume. It doesn't double the volume. It doesn't even take volume times 2 to the second. It takes volume and multiplies it by doubling 2 to the third power, or by 8. Alright, we've got one last problem to do here, and we want to find the composite volume of these 3 figures. We have a cylinder and 2 cones. Both cones have the same base as the cylinder. To find volume, it's very simple to do composite figures. All we have to do are take the 3 separate volumes and add them together. We're going to take them volume of cone 1 at the top, plus the volume of the cylinder, plus the volume of cone 2 at the bottom. Okay, so I'm going to let you find those individual volumes, 1, 2, and 3, and then add them together, and we'll check our answers in just a moment. So you'll need to pause the video, and then when you're ready, you may click play. We should get the 3 individual volumes as 5,145 pi, 15,435 pi, and 5,880 pi. When I combine those, I get a total of 26,460 pi, and then when I multiply by pi and round to the nearest tenth, we should get 83,126.5 cubic centimeters. Okay, that concludes our lesson on volume of cones and pyramids, and we will begin the assignment on this in class on Monday.